Hey everyone, welcome back to the channel. Today, we're stepping into the exciting world of chemistry to uncover the secrets of a compound you might not have heard of yet. 4-Acetamidobenzoic acid. Don't let the name intimidate you. We're going to break it down together. Whether you're a chemistry buff, a student cramming for an exam, or just someone who loves a good science story, this video is for you. We'll explore its structure, properties, where you can find it, and what it might be used for, all in a fun and easy-to-follow way. So grab your imaginary lab goggles and let's dive in. All right, let's get to the good stuff. What does 4-Acetamidobenzoic acid actually look like? Picture this. At its core, we've got a benzene ring. That's a 6-carbon ring with alternating double bonds, forming a sturdy, flat hexagon. Think of it as the foundation of this molecule. Now, attached to this ring are two special groups that give it its personality. On one side, we have a carboxylic acid group, written as COOH. That's a carbon double bonded to an oxygen and single bonded to an OH group, which makes this compound acidic, meaning it can donate a proton in a reaction. Then on the opposite side of the ring, at what we call the 4 position, there's an acetamido group, NHCOCH₃. This is a nitrogen atom bonded to a hydrogen and an acetyl group, which is COCH₃, a carbonyl group with a methyl tail. The 4 in the name tells us these two groups are positioned across from each other on the benzene ring, in what chemists call the para position. The image I've got here shows this beautifully, and its systematic name, C₉H₃, CONH6H4 CO2H, spells out this exact arrangement. Pretty cool, right? If you're following along, maybe sketch it out. It's a great way to see how chemists build these molecular puzzles. Now that we've got the structure down, let's talk about some of its key traits. The molecular formula is C₉H₉NO₃. That's 9 carbons, 9 hydrogens, 1 nitrogen, and 3 oxygens, all packed into this neat little package. If you're curious about its weight, its molar mass is 179.17 grams per mole. That's how much 1 mole, or about 6.022, times 10 to the power of 23 molecules of this stuff weighs, which is handy for lab work. Here's something interesting. It's a solid at room temperature, but if you heat it up, it doesn't just melt. It decomposes between 259 degrees Celsius and 262 degrees Celsius. That means it breaks apart into other substances rather than turning into a liquid, which is a big deal if you're experimenting with it. Oh, and it's got a unique ID in the chemistry world. Its CAS registry number is 556081. Think of that as its chemical fingerprint. Scientists use it to look up or order the exact compound they need. So, where can you get your hands on 4-Acetamidobenzoic acid? Well, it's not something you'll find at your local store. It's a bit more exclusive than that. The image shows it's available from a supplier with 2 options. Product code 15843-1A gets you 25 grams for 7,800 yen, and 15843-2A gives you 100 grams for 20,500 yen. That's in Japanese yen, roughly translating to about $70 and $180. Depending on the exchange rate, those prices might sound steep, and that's because this isn't your everyday chemical like table salt. It's specialized. This kind of cost hints that it's likely used in research labs or specific industries where its unique properties are worth the investment. So, if you're a chemist or a student working on a project, this might be on your shopping list. Just don't forget to budget for it. Now here's the million-dollar question. What's 4-Acetamidobenzoic acid actually used for? The image doesn't spill the beans directly, but we can play detective with its structure. That carboxylic acid group, negative COOH, is super reactive. It can team up with bases to form salts or with alcohols to make esters, which are common in organic synthesis. The acetamido group, NHCOCH₃, with its nitrogen and acetyl combo, feels like it could belong in the pharmaceutical world. Think about it. Similar compounds, like acetanilide, were once used as painkillers, so maybe this guy is an intermediate in making drugs like analgesics or anti-inflammatories. It could also be a stepping stone in creating more complex molecules for research or even material science, like polymers? I don't have the exact answer, so I'm curious, what do you think? If you know how this compound's used, drop it in the comments below. I'd love to hear from you. Before we wrap up, let's talk safety, because chemistry is awesome, but it's gotta be done right. Since 4-acetamidobenzoic acid decomposes at high temperatures, heating it could release some funky fumes, so you'd need good ventilation and the right setup. If you're working with it in a lab, gear up with gloves, goggles, and maybe a lab coat, standard protocol. Check the Material Safety Data Sheet, MSDS, for the full scoop on hazards and storage tips. It's probably stable under normal conditions, but keep it sealed and safe. This is why I love chemistry. It's thrilling, but it demands respect. So if you ever get to handle this compound, play it smart. And there you have it, our journey through the world of 4-acetamidobenzoic acid. We've unpacked its structure, checked out its properties, seen where you can buy it, and brainstormed its uses. I hope this sparked your curiosity as much as it did mine. If you enjoyed this deep dive, smash that like button, subscribe, and hit the bell so you don't miss our next chemistry adventure. Tell me in the comments, what compound should I explore next? Until then, stay curious, keep learning, and I'll see you in the next video.